For today's video, I'm going to be doing problem number 5 from section 5.3, which asks us to graph the integrand and use area to evaluate the definite integral. So we have for the definite integral that we want to evaluate, we have 7 and then the integral sign -7. And the function, derivative function here we have is square root of 49 minus x squared. And just as a note, when I look at the 7 and the -7, when we did a problem earlier in their homework with partitioning it and looking at that interval, when they had an interval and two x values between two things, that is kind of the same thing where we have -7 and 7. So those are kind of the interval of the function for the x values. So first, the step 1 is we're going to graph this function. And then we're going to use area under the curve or under that function, and that area is going to equal the definite integral. So I put this into my graphing calculator first, and when I put the 49, I'll rewrite the function. Square root 49 minus x squared. When I put this into my calculator, this part here, I got it to look like this. So here's my y and x axis, and it graphed out as a semicircle, and then I noted points of intersection. So this point here, and this point on the x-axis here, and I used it by looking at it, and then I confirmed it by looking at the table for the graph values. So here I have 7, 0, there I have -7, 0, and up here I have 0, 7. And this -7 and this 7 for the x values makes sense, since over here we're going between a -7 and 7 when we look at that interval of the x value. So then our step to find the definite integral is to find the area under the curve. So here's our curve here, and we're finding this shaded in area. So if we look at this, we know it's a semicircle. So the area of a semicircle is half of a circle's area. So I'll just dash in what the circle would be. So area is equal, a normal circle is pi r squared. And because it's a semicircle and we're having half of that, we can write that over 2, which is equal to the area of a semicircle. And this line right here on the y-axis, I'll draw just dashed lines so it looks different than everything else. This part right here is going to be our radius if you look at our circle. You could also do this as the radius right here, or you could do this as the radius right here. But I chose to do this for my radius. And if we go look, we know we're going up 7 units because it's at 0.07. So when y is 7 and x is 0. So we know our radius is going to be 7. So using r for radius is equal to 7. And then we just plug this into our equation. So area is equal to pi 7 squared over 2, which when we rewrite that, and I like to put my number before the pi symbol. 7 squared is 49. Pi all over 2, and we can't simplify this fraction down anymore. So the question was to find the area under the curve, and that will give us the definite integral. And so our answer for the definite integral is 49 pi all over 2. And that's how you do 5.3 number 5.